The year is 2274. Humanity has clawed its way past environmental collapse, and interstellar travel is no longer a science fiction trope. But the hunger for resources remains. This time, the target is not oil or rare earth metals, but something far more dazzling. Diamonds. Not just any diamonds, but the fabled Neptune ice, formed under unimaginable pressures and temperatures. These gemstones are rumored to be the size of your fist and possess unparalleled brilliance.
Are you sure this is the right spot? The scans are picking up readings like I've never seen before.
Relax. The simulations say this storm pocket is where the diamond rain condenses. We just need to get through the damn glitter and snag a sample before the pressure crushes us. They pilot their modified ice drill, a behemoth of reinforced steel and diamond-tipped machinery, into the heart of the glitter storm. Ice crystals as big as houses hurtle past, each glinting with an otherworldly luminescence. The roar of the engines is swallowed by the howling wind, a symphony of chaos that threatens to rip the craft apart.
Damn, the readings are off the charts. The pressure's building, we're not gonna make it.
Hold on. Deploying the gravity shield. There. We're stable. Now, quick, activate the drill. The drill screams into the icy depths, churning through layers of frozen methane and ammonia. Suddenly, a blinding flash erupts from the drill head. A geyser of liquid diamond, molten and swirling, spews upwards, threatening to engulf the craft.
We're caught in the diamond rain.
Reverse thrusters. Full power. We need to punch through the geyser and escape. In a heart-stopping maneuver, the ice drill rockets upwards, narrowly escaping the diamond torrent. They emerge from the storm, battered but alive, their cargo hold glowing with a celestial radiance. They have done the impossible, they have captured the glitter storm itself.
Welcome back, spacefaring explorers. We just witnessed the daring exploits of astronauts navigating the treacherous glitter storms of Neptune to harvest its legendary diamond rain. But is this fantastical adventure rooted in reality, or just a twinkle in a sci-fi writer's eye?
We're about to take a deep dive into the science behind Neptune's diamond rain. It's time to separate the cosmic myths from the hard facts.
First, let's ditch the Hollywood imagery. We're not talking about fist-sized gemstones raining down on fluffy clouds. Neptune's atmosphere is a swirling cauldron of hydrogen, helium, and methane, with temperatures reaching a frigid -214 degrees Celsius. The rain, if you can call it that, is more like a gentle snowfall of tiny nanodiamonds, formed under immense pressure and scorching heat deep within the planet's interior.
Think of it like this: imagine squeezing a lump of coal under millions of atmospheres of pressure, hotter than the surface of the sun. That's the environment where carbon atoms in methane rearrange themselves into the beautiful, tightly packed structure of diamond.
But how do these diamonds rain? It's all about gravity. As they form deeper within the planet, the newly minted diamonds are denser than their surroundings. So, they slowly sink, like tiny jewels falling through a cosmic hourglass. This descent generates heat, contributing to Neptune's powerful magnetic field.
This is still theoretical. Scientists haven't directly observed diamond rain on Neptune yet. But experiments on Earth, using diamond anvil cells that mimic the extreme conditions inside the planet, have successfully created nanodiamonds. So, the evidence is accumulating, and the hunt for definitive proof is on.
The key players in this cosmic jewel heist are pressure and temperature. Imagine Neptune's mantle like a pressure cooker on steroids, with pressures reaching a staggering 3 million to 10 million times the air pressure at sea level on Earth. That's enough to squeeze carbon atoms in methane molecules like grapes under a foot, forcing them to rearrange into the dazzling lattice of a diamond.
But pressure alone isn't enough. We also need heat, and oh boy, does Neptune deliver. The planet's core burns with fiery temperatures exceeding 5,000 degrees Celsius. This inferno sends waves of scorching heat radiating outwards, creating the perfect furnace for diamond formation.
Now, let's talk chemistry. Remember how graphite is essentially just diamond's messy cousin? Well, under Neptune's extreme conditions, hydrogen atoms break free from methane, leaving behind pure carbon, the building blocks of our coveted diamonds.
But here's the twist: Neptune's mantle isn't just a diamond factory. It's a chaotic cocktail of other chemicals, including ammonia, water, and even exotic ices like hydrogen sulfide. These additional ingredients might influence the diamond formation process, leading to the creation of unique diamond varieties with never-before-seen properties.
This complexity presents exciting challenges for scientists. Accurately simulating the conditions within Neptune's mantle is no easy feat. We rely on powerful computer models and sophisticated diamond anvil cell experiments to piece together the puzzle. And guess what? These efforts are already bearing fruit. Researchers have successfully synthesized nanodiamonds under simulated Neptunian conditions, providing tantalizing evidence for the real-life existence of this cosmic phenomenon.
But there's still a long way to go. Directly observing diamond rain on Neptune is a formidable task. The technology to probe the planet's depths with enough precision still eludes us. But the quest continues, fueled by scientific curiosity and the allure of these celestial jewels.
First, let's talk evidence. Remember the lab experiments that mimicked Neptune's internal conditions and successfully produced nanodiamonds? Those weren't isolated incidents. Multiple research teams around the world have replicated these results, strengthening the case for diamond rain's existence.
But Neptune isn't a giant test tube, and direct observation remains a hurdle. We can't send probes deep enough to witness the rain firsthand. So, we rely on clever detective work, piecing together clues from the planet's behavior.
One such clue comes from Neptune's internal heat. The planet radiates more energy than it receives from the sun, suggesting an internal heat source. Diamond rain, with its gravitational energy release, could be a significant contributor to this thermal mystery.
Another clue lies in Neptune's powerful magnetic field. The gravitational churning of diamonds within the mantle might play a role in generating this magnetosphere, an intriguing possibility currently under investigation.
Of course, challenges abound. Deciphering Neptune's complex internal structure from afar is like reading a book in a foreign language with missing pages. And even if we confirm diamond rain exists, understanding its full scope and scale remains a significant challenge.
Before we get lost in the dazzle of these celestial jewels, let's ponder a crucial question: if we can harvest these diamonds, should we?
This venture into cosmic mining raises a galaxy of ethical and philosophical considerations. We must remember, Neptune isn't just a resource bank, it's a world, potentially teeming with microbial life adapted to its extreme conditions.
Imagine the consequences of disrupting Neptune's delicate internal balance. Extracting diamonds, however carefully, could have unforeseen repercussions for the planet's climate, magnetic field, and even the potential biosphere lurking in its depths.
But let's not forget the potential benefits. These Neptunian diamonds could revolutionize technology on Earth, pushing the boundaries of materials science and medicine. Imagine lighter, stronger spacecraft or medical implants that mimic the incredible strength and biocompatibility of diamond.
The ethical tightrope stretches even further when we consider the ownership and distribution of these celestial resources. Who owns the diamonds of Neptune? All of humanity? The nations that possess the technology to reach them? What about the potential impact on Earth's already inequitable resource distribution?
This isn't just a scientific or technological challenge, it's a social, political, and philosophical one. We need a robust international framework to govern the exploration and potential exploitation of resources in space, ensuring equitable access and sustainable practices.
Ultimately, the decision to mine the diamonds of Neptune lies not just with scientists and engineers, but with all of us. We, the citizens of Earth, must engage in this crucial conversation, weighing the potential benefits against the ethical and environmental concerns. Only then can we chart a course that respects the cosmos and ourselves.
Thank you for joining us on this cosmic adventure. We hope you continue to explore the universe with curiosity and a sense of wonder.